Hello, today we're talking about applying derivatives. And in this case, we are finding our absolute extrema. Now, your extrema are your minimum and your maximum of a function on an interval. This is an interval, not an open plane. So what we look at here, this would be our absolute maximum and our absolute minimum. Note on this side, this minimum is lower than this one, but it's outside the interval. Same as this one, the maximum is higher than this maximum, but it's outside the maximum. That's in another lesson. It's outside the interval. Okay, what's essential to knowing how to find your absolute extrema is finding your critical numbers. Yes, they are critical. Remember, f is defined at c, so we'll just leave it there. So if f prime of c equals 0, of f is not sorry, I wrote the wrong word. This is supposed to be the word, excuse me, or. So, let's see, if f prime of c equals 0, or f is not differentiable, c is a critical number of f. So, an example of that we would use here. So our original function is f of x equals 3x to the fourth minus 4x to the third on the interval -1, 2, and these are on the x-axis. So first we take the derivative, and using our power rule we get f prime of x is 12x to the third minus 12x to the second. To find our critical number, we set it equal to 0, and then we solve for x. So we take out the common factor, and then we get x equals 1 or 0. And now what we do is we plug in our left and right endpoints and our critical numbers into the original equation. So that's the 3x to the fourth minus 4x to the third. And from there we find out where the minimum maximum is. So with our left endpoint, the function of -1 equals 7. With the first critical number, the function of 0 equals 0. With the second critical number, the function of 1 equals -1. And with the right endpoint, the function of 2 equals 16. Note I have minimum and maximum written on these two. That is because those are the lowest and highest points within the interval. Now another equation we can do is here, just as another example, we have the function of x equals 2 minus 3x to the 2/3 power on the interval -1, 3. So when we take the derivative, we get f prime of x equals 2 minus 2 over x to the 1/3 power, or it equals 2 times the quantity of x to the 1/3 minus 1 over x to the 1/3 power. So we set this equal to 0, and then x ends up equaling 1 and 0. So then when we plug in our left endpoint, we get f of -1 equals -5, and we get our critical number f of 0 equals 0, f of 1 equals 1, and f of 3 equals -0.24. Now we have our maximum, which is 1, and we have our minimum, which is -5, because those are the lowest and highest points within the interval. Good luck!